Right, so here we're going to have a look at the sum of natural numbers series. So it's 1 plus 2 plus 3 plus 4 plus 5 and so on out to infinity. And we're going to have a look at this result here. It's not so much equal to minus 1/12, but it's been assigned a value of minus 1/12. And it's used in various fields of mathematics like complex analysis, string theory, quantum field theory, and so on. But we're just going to have a look at where this value comes from. Now it's very counterintuitive in that, first of all, we're adding positive numbers and we end up with a negative value, and secondly we're adding whole numbers, positive whole numbers, and we end up with a fraction. So where does this solution come from? So let's have a look. Now let's just have a look at series first. We call it, I think we called it S initially in our first video, so we call it S again. 1 plus 2 plus 3 plus 4 plus 5 and so on. Now let's multiply both sides by 4, so we've got 4S, so that will give me 4 times 1, which is 4. Now actually what I'm going to do is I'm just going to extend this on a little bit further. Plus 6 plus 7 plus 8 plus 9 plus 10 and so on. Okay, so we're going to multiply both sides by 4. So 4 times S is 4 times 1, which is 4, and we're going to put that 4 underneath this 2 here. So 4 times 1 is 4. Plus, now 4 times 2, that's going to give me 8. So I'm going to skip 1 here, and I'm going to put that 8 underneath this 4 here. So I'm going to put that 8 here. 3 4 is 12. I'm going to skip 1. I'm going to put that underneath here. So that's going to be 12, and so on. 4 4 is 16, so I'm going to put that here. And 4 5 is 20, we'll put that here. Okay. Let's just see what happens if we subtract these two. So we'll put a line underneath here. And I'm going to take S minus 4S. S minus 4 times S. What do I get? Well, 1 minus 0 is just 1. 2 minus 4, that's going to give me minus 2. Here I end up with plus 3. 4 minus 8 minus 4 plus 5. 6 minus 12 minus 6 plus the 7 here. 8 minus 16 minus 8 plus 9 minus 10, and so on. So we end up with this particular series here on the right hand side, which we saw in a previous video. We assigned that a value of a quarter, I think it was, wasn't it? 1 over 4. Okay, so let's see what we can do with this. On the left hand side here we can factorize, so we can take the S outside the bracket. We end up with 1 minus 4. That's equal to a quarter. That gives me S times minus 3 here is equal to a quarter. Divide both sides by minus 3. So divide this side by minus 3, or multiply by 1 over minus 3 if you like. So that gives me minus 1 over 12. So my original series, which was S here, S, remember, is just 1 plus 2 plus 3 plus and so on. So S is minus 1/12. That's one way of looking at it anyway. So let's see if we can find another way of getting this result of minus 1/12. Okay. Right, so let's start again with our series. So we have 1 plus 2 plus 3 plus 4 plus 5 and so on. This is our series, and we call this S. Now what I'm going to do here is talk about a function called the Euler-Riemann function, or the Euler-Riemann zeta function. and this is this function here. It's a function in S here, and it is 1. Well, really 1 over 1 to the power of S plus 1 over 2 to the power of S plus 1 over 3 to the power of S plus 1 over 4 to the power of S, and so on. And well, this can be written as the sum of 1 over n to the power of S, where n goes from n is equal to 1 up to n here. Okay. Okay, so this is our series here, and this is the Euler zeta, the Euler Riemann zeta function, in fact. And Euler defined this on real numbers, Riemann defined it on complex numbers. We're just going to use this function to show our result here, that this function here is equal to 1, or we can assign it a value anyway of at least of minus 1/12. So let's have a look. First thing we're going to do is we're going to take this function here and we're going to multiply it by 2 to the power of minus s. So let's do that first. So let's look at the left hand side here. We're going to multiply by 2 to the power of minus s, our function. So we're multiplying here. So let's do that on the right hand side then. Well, if we multiply 1 by 2 to the power of minus s, we get 2 to the power of minus s. Multiply this by 2 to the power of minus s. Now, let me just do that. I'll just do one of these really, and then I'm just going to write down the results for the rest. So I'm going to multiply this here by 2 to the power of minus s. So I'll do it in a different color here. So I have 2 to the power of minus s, which is 1 over 2 to the power of s. This is my 2 to the power of minus s. I'm going to multiply 1 over 2 to the power of s by 2 to the power of minus s here. What do I get? That gives me 1 over 2 to the power of 2s, if you like. That's just 2 to the power of 2 to the power of s. Sorry, 1 over, that's, just go back a little bit here. That's going to be 1 over 2 to the power of 2 to the power of s. So that's just going to be 1 over 4 to the power of s. 1 over 4 to the power of s. So let me just write that out. So that's just going to be 1 over 4 to the power of s, or just 4 to the power of minus s. So that's where this comes from. Okay, you can continue that and you can do the next one yourself. It's the same kind of procedure again, but you will end up with 6 to the power of minus s. 3 times 2 gives you 6, and so on. So here you'll end up with, you can probably guess that this is going to be 8 to the power of minus s, plus, and so on. So all I've done is taken the zeta function here, on the left hand side multiplied by 2 to the power of minus s, on the right hand side multiplied by 2 to the power of minus s. Okay, now I'm going to take the zeta function and I'm going to subtract 2 times 2 to the power of minus s times the zeta function. So I'm going to take this minus twice all of this, if you understand that. Okay, so I'm going to I'll write it down anyway. I'll write it down in 2 lines here really. Let me just cordon this off here so I don't get mixed up here. So I'm going to take this here, my zeta function, in s, and I'm going to subtract twice this here, 2 to the power of minus s times zeta s. So that's what I'm doing, yeah? Now that's just going to be equal to, you can see you've got your zeta function here and your zeta function here. I'm just going to take that outside the bracket, so that will give me 1 minus 2 times 2 to the power of minus s, and this is all inside the bracket, and I can just, all I'm doing really here is factorizing. So I'm just taking my zeta function in s here. Okay, Now, on the right hand side then, what have I done? I've taken this minus twice all of this. So let me just write all that out. So I've taken the zeta function, this here, so I'll write that out first. So it's going to be 1 plus 2 to the power of minus s plus 3 to the power of minus s plus 4 to the power of minus s. That's this line here. Plus all of that there, okay. I'll just move up a little bit here. Now I'm going to subtract twice this here, okay, twice this. So it's twice minus twice 2 to the power of minus s plus 4 to the power of minus s. Now I'll write that over here, plus 4 to the power of minus s. Then I'll have over here, there'll be plus 6 to the power of minus s, and so on. Okay. I mean, I can write in here if you like. I can just continue this on just to include the 6. So this is 1, 2, 3, 4. I'll have 5 to the power of minus s plus 6 to the power of minus s plus, and so on. Okay. Now, let's just keep going then. What does this on the right hand side equal? Now, I won't write all this out again, that's just down here. That just comes down here. Okay, so what does this all equal? So I'll start off here with this 1 here, and I'm subtracting, well, I don't have to subtract anything more, I'll just write down the 1 again, okay. Now I'm going to take this one and this one here. Now, so I have plus 2 to the power of minus s minus 2 of these 2 to the power of minus s. That gives me minus 1 of them. So it's just 2 to the power of minus s. So I have plus 1 of these minus 2 of these, so that gives me minus 1 of these things here. I have plus 3 to the power of minus s here. Now I'm going to do these two here now. So I've got one of these 4 to the power of minus s's minus 2 of them. So that gives me minus 1 of them. So that's minus 4 to the power of minus s. I've got this plus 5 here, which I'm not doing anything with. And I'm going to do the same here. I've got one of these 6 to the power of minus s's minus 2 of them. So that gives me minus 1 of them. And so on. Okay. Right, now we've got this far. So what we can do now is just set s as minus 1. So I'm going to set s as let s here equal to minus 1. Let's see what happens. Okay, so I'm going to look at the left hand side here first. This is the left hand side, this is the right hand side here. So the left hand side here I'm going to set s as minus 1. So if I set s as minus 1 here, I have minus minus 1, which is plus 1. So really what I end up with here is 2 times 2, which is 4. So I have 1 minus 4, which is minus 3. Minus 3 inside the bracket here. So I've got minus 3 times my Riemann zeta function here. So that's just going to be minus 3 times this here. What do I end up with on the right hand side then? Now remember, I'm letting s equal to minus 1. So I get 1 minus 2 to the power of minus minus 1, which is just 2, minus minus 1 here, that's plus 1, so I just end up with plus 3. Minus minus 1 here is just plus 1, so here I end up with minus 4, plus 5, minus 6, plus, and so on. Okay, now what do I end up with on the left hand side? Minus 3 times the zeta function here is equal to, we know this here, we set that a value of minus 1/4. So again, divide across here by minus 3. Divide by minus 3. That means zeta s here is equal to, now I haven't said s is equal to minus 1 for my zeta function here yet, I'll do that in a second. Zeta function here is going to be equal to minus 1/12. Now remember we said s is equal to minus 1. Now what I should have done here was put the minus 1 into my zeta function here. I'm going to do that now, okay, because I've got my zeta function on the left hand side. So let's have a look at doing that. I have my minus 1/12 here on the right hand side here, so let's look at my zeta function. My zeta function, remember, is 1 plus 2 to the power of minus s plus 3 to the power of minus s plus 4 to the power of minus s plus and so on. Now if s is minus 1 here, my zeta function here is s minus 1 here, that's going to be 1 plus 2 plus 3 plus 4 plus and so on. So this here on the left hand side here is just going to be 1 plus 2 plus 3 plus 4 plus and so on equal to minus 1/12. And that's really the second proof, or second way of showing that we can assign a value of minus 1/12 to this function here. Now I should stress here that if you're asked about these functions, do they diverge, the three functions that I've spoken to in these three videos, do they diverge or converge? The answer is they all diverge. Are they equal to these values? A quarter, a half, minus 1/12, they're not strictly speaking equal to them in the standard sense. You have to do these Cesaro convergence methods and this kind of method here to show where these minus 1/12 and quarters and halves come from. So if you're asked they are divergent, the partial sums fail to converge to a finite limit. So the series, these three series don't have a sum as such, okay? But these solutions that we've come up with, as I say, are useful in some more advanced topics in maths, like, as I say, string theory and quantum field theory and so on.